Hi class. The purpose of this video is to just mention a couple of things from last week and to show what I hope is a helpful table for understanding volcanoes this week. So on this slide, we have our rock cycle with the blanks from the rock cycle game. And I thought I'd add some color. So we have this slightly different version in the middle here. And if we rotated this about 90 degrees clockwise, then it would pretty well align with our rock cycle version, our rock cycle game version. So I did mention that this would be kind of our roadmap as we go through some of the next modules. And sure enough, we're in the midst of igneous rock. And this next week, we'll be talking about weathering and sedimentary rocks. And along the way, we'll be talking about sediment. Now, in our rock cycle, we had weathering and erosion, and you often hear those two words together. This one says weathering and lithification, and lithification means turning into rock, forming rock. Whenever you see that TH, lith means rock, lithification. So you're making sediment with the weathering, and whenever you get weathered, broken rock that gets broken down, you're forming sediment. The sedimentary rock is actually formed. So weathering and erosion is probably preferable to this. Okay, one other thing. On the diagram that goes along with the rock cycle game, there might be a couple more arrows that could be added, and there might be extra credit available for those that tell me where those arrows would go and what they should be labeled. Here's a picture of obsidian. And in your igneous rock identification, I intentionally did not put in this really easy identification because if you look at the table, you'd see it over on the light-colored rock side, felsic, and there's just nothing light-colored looking about this. So the unfortunate circumstance is that obsidian is made up of 70 to 75% SiO2. That's also the chemical formula for, I should say that is the chemical formula for quartz. And that tends to be pretty transparent usually, or light colored. But this has lots of inclusions that make it look dark. But really on the inside, it's mainly a felsic rock. But that really messes up what people might put for an identification. So I just left that one out of that series. Okay, next is this table that I hope for volcano work. Basically, it organizes information. So you might see some patterns here, especially on the left-hand side of the table. Like there's a lot of lows along the top and a lot of highs along the bottom. That's bound to simplify things. Okay, so what are these columns? Viscosity, gas content, gases like water and carbon dioxide especially, tendency to form pyroclastics. Clasts are pieces of rock. Pyro refers to fire rocks, volcanic rocks, pieces. Typical volcanic landform and examples. Okay, let's go back here to the silica content. Lots of silica means light-colored rocks. So there'll be lots of silica in the rhyolitic rocks, high silica content, low in the basaltic. Viscosity. Viscosity is the resistance to flow. Okay, the basaltic rocks with the low silica content don't have much resistance to flow, so they flow. And they flow to form shield volcanoes. you don't have a lot of thick lava coming out, building up. And you don't have, well, you stop there. Say that like on the Hawaiian Islands, you have these big low islands, the shield shape. With the rhyolitic, there's a high silica content, high viscosity. Okay, and think about something that's very viscous, thick. For me, what I think of is when I'm making pudding or ice cream, and I mean mixing from scratch and boiling this pudding-like mixture. And as it gets thick, and I like to make, especially for pies, make this stuff thick so it'll stand up and not be flowing all over the plate when you cut a piece of pie. But what happens is it's so thick that as the bubbles form, oh man, they get gas trapped in them, and then they explode. Then I end up with all this hot pudding mixture all over my arms. It's not fun, but I mean, it's good when I'm all done. Okay, so that's what happens with this rhyolitic high silica magma and lava when it comes out. Very thick, it traps gas, and it just explode. This is going to be your more explosive kinds of volcanoes. And you'll get the pyroclastics, those pieces that shoot out of the volcano, and you get your tall, steep composite or stratovolcano cones. This would be like Mount St. Helens, Mount Vesuvius. Now this andesitic row is left blank. Okay, so there's another type of cone, cinder cones, that's left out of this column. Well, cinder cones in Sunset Crater in our own state of Arizona, they can be a bit complex. And andesitic compositions can be a bit complex. So I thought I'd leave it at the extremes, the basaltic and the rhyolitic. And you can learn more about these and cinder cones as you go through the unit. Thanks for listening. Bye for now.